By the end of this module, you should identify the main components of air source heat pump, and explain the unique components of air source heat pump.
Air source heat pumps are energy-efficient heating and cooling systems that use the principles of thermodynamics to transfer heat between the indoor and outdoor environments. They are commonly used for residential and commercial heating and cooling applications. Air source heat pumps extract heat from the outdoor air during the heating season to provide warmth inside a building, and they can reverse this process to cool indoor spaces during the cooling season. An air source heat pump is a complex system consisting of several key components working together to transfer heat between indoor and outdoor environments. Let's explore these components. Evaporator, condenser, compressor, expansion valve, piping and tubing, sensors and control systems, and oil separator and accumulator. Air source heat pumps exhibit several key characteristics that render them popular for heating and cooling, heat transfer, energy efficiency, environmental friendliness, versatility, and zoning capability. Heat transfer. Air source heat pumps proficiently transfer heat in both directions, enabling efficient heating in winter and effective cooling in summer. Energy efficiency. Air source heat pumps are recognized for their superior energy efficiency, delivering more heating or cooling energy than the electrical energy they consume. Environmental friendliness. Air source heat pumps are environmentally friendly, emitting fewer greenhouse gases, particularly when powered by renewable energy sources. Versatility. Air source heat pumps are versatile, suitable for various applications including space heating, cooling, and domestic hot water heating. Zoning capability. Air source heat pump systems often support zoning, enabling precise control of heating or cooling in different areas or rooms, enhancing comfort and energy savings. In addition to the key components, some air source heat pumps may feature unique components to enhance functionality and efficiency. These unique components include defrost system, desuperheater, and electronic expansion valve. Defrost system. Air source heat pumps in colder climates may include a defrost system to prevent ice buildup on the outdoor coil during heating mode by temporarily switching to cooling mode. Desuperheater. Certain air source heat pumps utilize excess heat from the compressor during cooling mode to heat domestic hot water, enhancing overall system efficiency. Electronic expansion valve. High-efficiency air source heat pumps may incorporate an electronic expansion valve for precise control of refrigerant flow, resulting in improved performance and efficiency. Here is the list of advantages of the air source heat pumps. Energy efficiency, ease of installation, versatility, no fuel storage, and environmental benefits. Energy efficiency. Air source heat pumps are known for their high energy efficiency. They can provide more heating or cooling energy than the electrical energy they consume. This efficiency can lead to cost savings on energy bills. Ease of installation. Air source heat pumps are relatively easy to install, especially when compared to geothermal heat pumps. They do not require extensive ground loop installation or excavation. Versatility. Air source heat pumps can provide both heating and cooling, making them versatile for year-round use. They can be used in various applications, including residential and commercial spaces. No fuel storage. Air source heat pumps do not require fuel storage, such as natural gas or oil tanks, which can be a safety and space consideration. Environmental benefits. Air source heat pumps produce fewer greenhouse gas emissions compared to traditional heating systems, especially when powered by renewable energy sources. They can contribute to reduced carbon footprint. Here is the list of disadvantages of the air source heat pumps. Weather dependence, initial cost, electricity dependency, and space for outdoor unit. Weather dependence. Air source heat pumps' efficiency may decrease in extremely cold climates, as they extract heat from the outdoor air. Supplemental heating may be necessary in such conditions. Initial cost. The initial purchase and installation cost of air source heat pumps can be relatively high, which may be a barrier to some homeowners. Electricity dependency. Air source heat pumps rely on electricity to operate, so their efficiency and cost-effectiveness are subject to electricity prices and availability. Space for outdoor unit. Air source heat pumps require an outdoor unit, which can take up space and may not be suitable for all property types. Air source heat pump has different components, each with a specific role. So, just like a team, these furnace components work together seamlessly to ensure our homes stay toasty when we need it most.